Hey guys, welcome to the channel. Today we will be building a smart PDF agent that can help you answer your question throughout the PDF. So how it will work, we will be utilizing the LangChain and Ollama to build this, and then we will ask any questions that we want from the PDF, and the LLM will generate the answer for you using the PDF context. Let's dive in. Are you tired of reading long PDFs and not getting nothing out of it? So this is a very huge PDF that I wanted to read but could not read, right? So that's where this PDF parser comes in. So whatever, I can simply ask my PDF, okay, what is the information that you have? So we can ask the question, what are the topics this book covers? So once we fire the query, it fetches all the laws which are being mentioned in this particular PDF. So to run local LLM, what you can do is you can install Ollama. How you can install? Go to ollama.com official website, download the particular version. If you are running on macOS, then download the macOS. Windows, Linux is also there. I am on Mac, so I'll download this one. Once you download this package, you can install and check if the things are fine. So you can run the command Ollama list. So if you are running for the first time, you will see this particular list is empty. And then what you need to do is you need to pull some models. So then you can go to this models tab and then check out there are different models available on this page. So what I have experimented with Gamma 3, DeepSeek R1 and Llama 3.3 and other models. So there is a tag also you can filter if you want to see embedding models or the tools or the particular vision models. So for now, I'm not going into the detail. So this once you click on any of the model, let's say Gamma 3 you want to use, and you can see there is a command to run particular model. Ollama run Gamma 3, right? So I'll just hit that command. If you are running this for the first time, it will download the particular package and it will download the model into your local machine. So for example, you can see all the sizes here. For Gamma 3 4B is of 3.3 GB, and this is what it is shown here also, right? So you can see if everything is done, you have already downloaded, it's the one-time job. If you have already downloaded this package, then you don't have to do anything. Now what you can do is you can run Ollama Gamma 3 command, whatever is mentioned, whatever the model you are trying to use here, and simply you can write chatting with your model. So I just typed hey and then how's it going. One thing to notice, whatever model you download is trained for a specific date in the past, right? So let's see how old this model is. So what I simply ask is what's today's date. So then you can see today is Wednesday, November 1, 2013. So it's somewhere, this particular model is trained somewhere around November 2013. So this will not give you the latest information if you try to directly run it. So if you remember, I just showcased how you can install the LLM on your local machine. Now we are going to use it into the particular application. So how we can utilize is, so LangChain Ollama provides out of the box class which you can instantiate with the model name. So for example, I downloaded Gamma 3. So it is going to use the Gamma model, and then we will initialize this particular LLM instance. I'll also explain what each of these fields mean. So embedded modeling is when you require your PDF to be embedded into a vector store. We'll come them back to that later. These are the some configuration that are required by the API to trace your projects. This is our dummy API key, and these all are like project Langsmith tracing that you can set up to monitor how the things are going. So for example, if I go to my tracing and if I select my project, then you can see all the LLM calls that I made from my local machine are being listed, and then you can see what are the steps or the traces that being run in the parallel. So for example, enable sequence run, then Ollama LLM run, and then you can see what was system prompt, what was the context, and then what was the output of this uh, particular prompt. Okay, from this point we'll start building our Streamlit application. So first thing we'll do is We'll import the streamlit, and then LangChain imports, which is prompt, vector store, output parser, and document loader, which is PyMe PDF loader. Right. After that, we'll initialize the Ollama imports by importing local LLM and the embedding model from the base model. After that, we will initialize our vector store, and we'll maintain the state for this. So why this is required is so that whenever you refresh, rerun your application, you are not embedding the same PDF again and again, right? So next up, we'll generate a generic system prompt to answer any questions related to the document. So we'll create a chain using the chat prompt template and str output parser, which will nothing but return the answer, whatever the answer is. Now it's a utility function to load PDF files into the folder that user will upload. So for example, this particular PDF, let me delete all these so that we can start fresh. Yeah. Then we will initialize our app. Let your PDF do the talking. This is the title that we are going to build. Then we'll initialize the container. This is nothing but whenever you run a LLM model, it may may or may not return the different result on different runs. So this is just a warning I'm printing. Next up, we'll initialize the information container, which will say upload your PDF and what will happen in this particular application. Next up, we'll have a file uploader in place. Then we will build some checks around it. For example, if the uploaded file is already processed, then we will not upload. Otherwise, we will upload the file. Then we will add the PDF parsing by loading it using the new PDF loader, and then storing it into the vector store. So right now I'm indexing only 100 pages, but you can build if you can build anything you want. Then next we will notify the user if the PDF is generated successfully. Next up, we will create a container. If the file is processed, then user can ask anything for the questions over the PDF. Then what will going to happen is we will search from the vector store the related document, and we will provide those related documents to the LLM, and then we will ask LLM to generate the answer for this particular question that user is asking based on the context provided in as the related documents. So this is pretty much the complete application is. So now that our application is ready, we are going to run this particular application, streamlit run main.py. This is going to spin up a project, and then we'll see what. So this is all the application that we have made. We will browse the files, and let's say I'll upload this particular graph theory PDF, which is a long PDF, explains about the different concept of the graph theory. So I see the PDF documents are indexed into the vector store, and it is ready to use the questions. So let me ask this question: what's the minimum spanning tree? What is minimum spanning? So once I fire a question, it fetches the vector store and analyze what are the documents that can be matched with particular question. So once we fire this LLM, it provides all the recommended documents to the LLM. Now LLM parses those documents and then generates a definition out of it. Now let's try with some other PDF. I have this atomic habit PDF. We'll analyze this. So PDF upload has successfully. PDF document is now indexed. So we can ask the question, what are the topics this book covers? So what are the mentioned in this book? So once we fire the query, it fetches all the laws which are being mentioned in this particular PDF. You can trace your projects. So I'm using this developer version for now, but this particular Langsmith has a different category to trace whatever models you have run till now and what are the success rate, all those other things, right? So this is all the queries that I fired using my local LLM. It also tracks local LLM, right? So this is the stats: total tokens used, median token, number of error rate, percentage of streaming. So this is all the basic things. Then you can go to monitor tab to check how many LLM calls happened, how many LLM call were success, how many traces were there, right? Then you can go into the specifics of this. So for example, I ran this author name, right? So what happened? So based on the author name, it fetched these documents. If you like this video, please give a thumbs up and subscribe to the channel so that you never miss an update for my upcoming videos. Until next time, happy coding, peace out.